Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are in module number 2, lecture number 14 on conic sections. In that we have covered focus directrix method, concentric circle method, rectangle method or oblong method, and in today's class we will look at arc of circle method. In this arc of circle method, an ellipse with major axis is known, perhaps let us say in this case 100 mm, and the distance between foci is known, something like 70 mm. If that is the case, how to construct an ellipse? So, let us look at the steps. First of all, we have to draw major axis AB 100 mm and locate the midpoint O. Draw major axis AB 100 mm and locate midpoint O. So, point A, point B, this is 100 mm, and at 50 mm we are going to locate O. Once it is done, locate foci. Once it is done, locate foci F1 and F2, those are F1 and F2 on AB such that F1O and OF2 are 35 mm each. Major axis is 100 mm and distance between foci is 70 mm. That means, we have to mark a division from O, here this is 35 units and this one also 35 units. Our standard practice is we do not show these dimensions on the drawing, somewhere outside we have to extend those lines and show it. So, once we locate this F1 foci, F2 focus, then we will go with the next step. Now, we have to mark suitable number of points, something like 1, 2, 3 on AB between F1 and F2. F1 and F2, it can be equal or any number of points. It is easy always to go with equal number of points as a uniform grid, first point, second point, third point, fourth point. Once it is done, with F1 as center, so F1 is center, the distance from A to 1, this distance let us measure it. With that distance from F1, make an arc something like that on both the sides. So, center has to be F1, but the distance is A1, A to 1 whatever the distance, make an arc on top and bottom on either sides of AB. Now, with focus F2 from here as a center and radius B1. So, B is here, B1 is that. So, with B to 1 distance, but center is F2, make an arc in this direction. Similarly, make it on that side. Once we are done, we will have this point P1 and P1 prime. these are F1 and this is F2 and this is also F2 and this is F1. Now, if we are moving to the second point, to construct P2, what we have to do is from A to 2, whatever the distance, use that distance, but center as F1, make an arc on either side. Similarly, from B to 2 distance, whatever the distance, F2 as center, make an arc on both sides. Whatever the intersection point, let us call P2, P2 dash or P2 prime, in such a way that A to 1 distance plus B to 1 distance always gives us major axis 70 mm. Let us look at this. This is A1, and B1 is this. So, if we are going to add these two distances, it is supposed to give us major axis 70 mm. Similarly, if we are using A to 2 distance and B to 2 distance, thus also consists of A2 plus B2 distance, that is also 70 mm. In that way, we will be going to construct P2 point, P3 point and so on things. So, let us begin our example, construct it step by step. Major axis 100 mm. So, let us look at on this drawing sheet. So, let us mark 100 mm on this drawing sheet. Let us call A and B. Then we have to look at center, which bisectors we can use it. Otherwise, 50 mm also we can use. In this case, join this line. These points we have to connect. So, this is center of the circle, call O. Now, we have to look at foci, which is at 35 mm on either side. So, let us mark 35 mm scale. So, this is one of the foci, the other one is at 70 mm. So, call these points F1 and this point F2. After that, we have to take distance A to 1. For that, we have to arbitrarily or equal divisions we can take it. Let us take equal divisions. So, it is 35 mm. So, we will like to mark after every 7 points. So, 35, 7 5s are 35. So, 6, 7, 14, 21, 28. Similarly, here one can make 35, next 42, 49, and so on. Once this division is done, we have to measure distance A to 1. Let us name them as 1, 2, 3, 4, 5, 6 and so on. A to 1, whatever the distance, use your compass A1, use F1 as center, mark an arc on both sides. From B to 1 also we have to find the distance. This is the one. Use foci as F2, make an arc. Call that intersection point as P1, P1, P1 dash, P1 prime. Now, A to 2, pick that point. This is A to 2, centered around focus on both sides. Then B to 2, whatever the distance we get, use F2, intersect this curve, which is A2. So, mark this point P2. Similarly, use A3 distance, center around F1, B3 distance, center around F2, mark it. A3 distance on both sides. Once we construct this P3 here and P3 there. Now, we will be in a position to join a smooth curve. Using French curve, it will be better and so on. Similarly, we will be in a position to construct a line which pass through P3. In that way, we will be in a position to construct all that curve which pass through B point and also this point. So, that we will be in a position to construct ellipse. This is by arcs of circle method. In this case, we require major axis. So, if it is construction lines, we have to show mm. Foci distance also we know. So, smaller dimensions will always be inside. That is the standard convention what we are going to use. The construction procedure can be much lighter also instead of darkening it. So, this one is 70 and this one is 100, the distance between foci. Now, we will ask a question, how to draw a tangent and normal to an ellipse. For example, part of the curve we have constructed as an ellipse. Now, pick any point where we would like to construct a normal or tangent. In this case, we would like to construct, for example, at point R. So, this is the ellipse which we have joined, and our intention is to construct something like normal to that. For that purpose, what we have to do, after deciding where you would like to draw the normal or tangent, connect that point R with focus F1. Similarly, join this R with focus F2. Now, we have an angle, we have this angle F1 R F2. Now, based on the center somewhere distance, we just make an arc, we have to bisect it. So, from there again with the same radius make an arc on both sides. So, we will have some point and extend that. So, it makes equal angles on both sides and this point extend it. If we can do that, that is what we call normal. So, to an ellipse, this is the way we construct a normal. Tangent always be 90 degrees and touch at only one point passing through R, and we will be in a position to construct tangent. If some other point here, then we will join F1 point. For example, let us look at, we would like to construct a normal there. What we do is connect this F1 and this point, similarly connect this F2. Now, make a bisector, join it, construct normal, this is normal and that will be tangent. If one would like to construct normal here, what to be done? Think about it. Precisely on major axis or minor axis, you would like to construct normal. Will that be straightforwardly this one, or do I have to join the lines from F1, F2 and bisect it? So, let us look at it carefully. If the point is straight away at major axis, on major axis, the procedure, the general procedure, connect any point on that curve with two foci. So, if I am going to connect point B with F1, the line will be this one. Similarly, this point we are going to connect with F2. That means, for this point B, again connect that. Both are still making that 0 degrees or 180 degrees kind of thing, the equal division which comprises of same line. So, this is the one which makes normal to that circle at this point, and tangent will be perpendicular to that. This will be same thing happens here, normal will be in that direction, tangent will be in that direction. If we are picking C point, normal will be in that direction, tangent will be in other direction. Except these 4 points A, B, C, D, at remaining points, this normal angle continuously increases as you go in that direction, all the way from 0 angle to 90 degrees it increases. So, let us construct this normal and tangent on sheet. So, we have a part of the curve here on the drawing sheet. Now, let us identify a point something here. Let us consider this is the point where I would like to construct normal on the drawing sheet here. Now, the procedure is join this F1 with that point, is a construction line. Similarly, construct join this F2 with that particular point. Now, this is the point what we are identifying. Now, use angle bisector division for that purpose. What we have to do is pick anything like arbitrary radius. Now, use this intersection point with the same radius, intersect this curve, locate this point and join this point with this one. This will be the normal M n, and the tangent always be perpendicular to that. So, we can use a set of squares, these such squares we can use it, align that, or perhaps your drafter is the best way to construct these perpendicular lines and extend this line. So, we have this tangent S T, arc of circle method, and we have learned how to construct both tangent and normal. So, in today's lecture we have covered this arc of circles method. So, in principle, to construct ellipse the popular methods are 4: focus directrix method, a concentric circle method, oblong method and arc of circle method. In focus directrix method we know something like a directrix, eccentricity we know, equally divide distance between these any point on the curve by equal number of divisions, draw 45 degrees line and intersect it and construct this ellipse. In concentric circle method we have major axis, minor axis, and two circles we draw, two concentric circles. By horizontal and vertical projections on equal number of divisions we will construct this ellipse. In rectangle method or oblong method what we have is major axis, minor axis, a rectangle, in some cases parallelogram also we will use to construct equal number of divisions on the major axis, minor axis, connect minor axis elements with major axis elements and get the intersection lines. From there construct this ellipse. In arc of circle method we have seen major axis is given, the distance between foci is given. So, using a principle, any point where we would like to construct this ellipse, A1 plus B1 always be major axis length. Using that principle and radius as F1, F2 the foci centers, make many arcs, intersect them and construct an ellipse. These are the ways we construct ellipse, and especially focus directrix method is quite popular. One, because from directrix we know the distance and eccentricity we know. That means, in the last classes we have seen an ellipse is having eccentricity less than 1, parabola is for parabola eccentricity is equal to 1 and for hyperbola eccentricity is greater than 1. That means, if we know the directrix distance and eccentricity, in principle we will be in a position to construct, it can be ellipse, parabola, hyperbola. And in next class we will look at these 4 methods, especially focus directrix method, rectangle method, and there is a special case like tangent method to construct parabolas, and how to draw tangent and normal to parabolas also we will see. Thank you.